Is there a relation between the principle that superconductors push magnetic fields and spin? Yes. The principle by which a superconductor expels magnetic fields is known as the Meissner effect, or Meissner-Ochsenfeld effect. This phenomenon occurs when a superconductor is cooled below a certain critical temperature, at which its electrical resistance disappears, and it expels magnetic flux lines from its interior, effectively pushing out the magnetic field. Moreover, the behavior of superconductors is indeed related to the concept of spin in quantum mechanics. Spin represents the intrinsic angular momentum of particles, such as electrons. Superconductors' electrons exhibit specific spin states that are connected to their unique physical properties, and these spin states play a crucial role in the manifestation of the Meissner effect. Does it mean that superconductors generate magnetic field lines on their own even though no current passes through them? Correct. Superconductors exhibit the Meissner effect, which means that even when no current is flowing through them, they generate magnetic fields that push out magnetic flux lines from their interior. This unique phenomenon occurs below a critical temperature where the superconductor's electrical resistance disappears. As a result of the Meissner effect, superconductors can be used as magnetic shields to exclude magnetic fields, creating an environment that remains unaffected by external magnetic influences. This property finds extensive applications in various fields. Then, if the superconductor pushes the lines of magnetic force, on the contrary, if the position of the superconductor is reversed, the effect of pulling the lines of magnetic force will also occur. The phenomenon of a superconductor pushing out magnetic flux lines and creating a magnetic field is known as the Meissner effect. However, flipping the position of a superconductor will not reverse this effect and cause it to attract magnetic flux lines. The Meissner effect is a property of the superconductor's internal electron behavior and is independent of its position. Therefore, flipping the superconductor's position cannot reverse the Meissner effect, and alternative methods need to be employed if one wants to generate a magnetic field that attracts magnetic flux lines. So, do superconductors and superconductors repel each other? Yes, that's correct. Two superconductors positioned close to each other will repel each other. This repulsion occurs due to the generation of magnetic flux lines between the two superconductors, leading to an opposite directional push. As long as the two superconductors remain relatively stationary, they will continue to exert repulsive forces on each other. This property finds applications in stable levitation devices and magnetic levitation technologies utilizing superconductors' magnetic repulsion. However, generating strong repulsive forces between two superconductors requires specific conditions, and under normal circumstances, the effect is relatively weak. Then, is there no material that attracts superconductors? There is no substance that attracts superconductors. There is no substance that attracts superconductors. The Meissner effect of superconductors is a phenomenon where they expel magnetic fields below a certain critical temperature. As a result, other substances do not cause superconductors to be attracted by magnetic fields. Generally, magnetism is determined by the magnetic field, and since superconductors have the property of expelling magnetic fields, they are not drawn towards other substances by magnetic fields. However, other magnetic materials can be influenced by the magnetic field around superconductors, leading to interactions between them. Such magnetic field interactions are studied and utilized in various applications using different magnetic materials and superconductors.